Picture the Iraqi desert in February 1991. The Battle of 73 Easting. Captain H. R. McMaster and Eagle Troop cresting a ridge. The thermal sights cutting through a blinding sandstorm. The American M1 Abrams obliterating the Iraqi Tawakalna division before the enemy T-72s even knew they were in a fight. That is the legend. The undisputed heavyweight champion of the armored world. But fast forward to the modern battlefield. Today, we see grainy drone footage of multi-million-dollar Abrams tanks immobilized in muddy trenches, their turrets popped, defeated by cheap commercial drones, or hidden anti-tank mines in Eastern Europe and the Middle East. It forces us to ask a very uncomfortable question. Is the M1 Abrams the ultimate battlefield legend, or has it always been an overrated paper tiger, propped up by American air superiority and weak adversaries? Welcome back to the War Room. I am your host, and today we are tearing apart the myth, the metal, and the math behind America's main battle tank. If you want hard-hitting tactical analysis without the Pentagon public relations spin, hit that subscribe button right now. Drop a comment below and tell me if you think the Abrams is obsolete in the age of drone warfare. Let us get into it. To understand the Abrams, you have to understand the sheer panic that birthed it. We have to rewind to the 1960s. The United States and West Germany tried to build a super tank together, known as the MBT-70. It was a bloated, over-engineered disaster. It featured a hydropneumatic suspension that constantly broke down and a 152mm gun launcher that was supposed to fire Shillelagh-guided missiles, but mostly just jammed. It was a classic case of defense contractors trying to build a Swiss Army knife when the Army just needed a sledgehammer. By 1971, the United States Congress mercifully killed the MBT-70 project. But the Soviet Union was not waiting around for America to figure out its procurement issues. The Soviets were actively deploying the T-64, a revolutionary tank with an automatic loader and composite armor that sent shockwaves through Western intelligence agencies. Then came the Yom Kippur War in October 1973. This was the true wake-up call for military strategists globally. Over 2 brutal weeks of fighting in the Sinai Peninsula and the Golan Heights, the Israelis and the Arab coalitions lost a combined total of nearly 3,000 tanks. Let that number sink in for a moment. 3,000 tanks destroyed in 14 days. The introduction of the Soviet-supplied AT-3 Sagar wire-guided missile and the RPG-7 proved that a single infantryman hiding in a ditch could now kill heavy armor at a distance of 2 miles. Did the tank just become obsolete? Many defense analysts in 1974 certainly thought so. They looked at the burning Israeli M48 Pattons in the desert and declared the era of armored cavalry dead forever. But the Pentagon realized something entirely different. The tank was not dead, it just needed to evolve past cold-rolled steel. It needed the ability to shoot first, move faster, and take a direct hit without vaporizing the crew inside. Enter the XM1 program. The United States Army desperately needed a new tank to defend the Fulda Gap. The Fulda Gap was a prime invasion route, a lowland corridor where the Soviet 8th Guards Army was expected to pour out of East Germany in the event of World War III. The battlefield math was absolutely terrifying. The American 5th Corps stationed in Europe would be facing a Soviet armored steamroller that outnumbered them 3-1. Think back to the Battle of the Bulge in 1944. American M4 Shermans were heavily outgunned and under-armored compared to the German Panther and Tiger tanks. It notoriously took 5 Shermans to kill 1 Panther, or so the grim battlefield mathematics went. The United States relied on sheer industrial volume to win that armor war in Europe. But in the 1970s, against the Soviet Union, the United States could never win a war of industrial attrition. The Soviets simply had too many tanks. The United States needed a massive qualitative overmatch. They needed a machine that could kill 3 T-72s, survive a direct kinetic strike, and retreat at 40 miles per hour to the next fighting position before the enemy artillery could zero in. Let us look at the competing military doctrines that shaped this era. The Soviet deep battle doctrine relied on mass, momentum, and continuous echelons of armored vehicles. Their tanks, specifically the T-72, were designed to be cheap, low-profile, and expendable. They operated with a 3-man crew because a mechanical autoloader replaced the human loader. This design choice made the turret significantly smaller and harder to hit, but it also meant the crew was sitting directly on top of a carousel loaded with highly explosive 125mm ammunition. A penetrating hit from an enemy round usually meant a catastrophic ammunition detonation, resulting in the infamous turret toss that instantly killed everyone inside. The American air-land battle doctrine, finalized in the early 1980s, was completely different. It relied on active defense, combined arms synchronization, and overwhelming precision. The Abrams was explicitly designed to fight outnumbered and win. To achieve this impossible standard, Chrysler Defense, which later became General Dynamics Land Systems, made three radical engineering choices that would define the Abrams forever. First, let us examine the power plant. Why put a jet engine in a ground vehicle? It sounds like the fever dream of a mad scientist. But the Honeywell AGT 5500 gas turbine engine was chosen for a very specific tactical reason. It delivered a staggering 1,500 shaft horsepower. It gave a 60-ton chunk of metal the acceleration of a sports car. It was omnivorous, meaning it could run on JP8 jet fuel, standard diesel, marine gas, or even high-octane gasoline if a crew was desperate enough. More importantly, it was incredibly quiet. Soviet infantry could hear a rumbling diesel engine from miles away. The Abrams turbine, however, emitted a high-pitched whine that blended into the background noise of the battlefield, earning it the terrifying nickname Whispering Death. But this performance came at a brutal logistical cost. The Abrams measures its fuel consumption in gallons per mile, not miles per gallon. It burns roughly 10 gallons of fuel, just starting the turbine engine, and nearly 2 gallons per mile while moving cross-country. Does a 70-ton behemoth with a jet engine actually make sense in a mud-soaked European winter? The logistics officers certainly did not think so. Let us talk about the massive logistical tail required to keep this beast alive. An armored division is a hungry, demanding entity. To keep just one single battalion of Abrams tanks moving, you need a massive fleet of heavy expanded mobility tactical trucks, known as HAMTTs, constantly shuttling thousands of gallons of highly flammable jet fuel to the front lines under fire. You also need M88 Hercules recovery vehicles, which themselves weigh over 70 tons just to tow a broken or disabled Abrams off the battlefield. If a smart enemy destroys your soft-skinned fuel trucks, your fleet of invincible super tanks instantly becomes a collection of very expensive stationary pillboxes. Look at the German Tiger tanks in World War II for a historical parallel. They were technological marvels of their time, boasting the feared 88mm gun and virtually impenetrable frontal armor. But they were over-engineered, incredibly thirsty, and broke down constantly. When the Allied bombers destroyed the German fuel supply lines and rail networks, the mighty Tigers were simply abandoned or blown up by their own crews. A tank without gas is just a steel coffin. The Abrams designers knew this severe risk, but they bet the farm on American logistical supremacy. They assumed the United States military would always control the skies and maintain secure supply lines, a luxury not every nation possesses. Second, we have to analyze the armor. The Abrams was the first American tank to utilize Chobham armor, originally developed by the British at their research facility in Surrey. This was not just thick sloped steel. It was a highly classified composite matrix consisting of ceramic tiles, steel alloys, and other proprietary materials designed to shatter and absorb the kinetic energy of shaped charges and armor-piercing darts. Later variants of the Abrams, starting in the late 1980s, incorporated depleted uranium mesh directly into the frontal hull and the turret cheeks. Depleted uranium is 2.5 times denser than regular steel. It made the Abrams virtually impervious to frontal attacks from the standard Soviet 115mm and 125mm guns of that specific era. But this incredible protection pushed the weight of the tank from its original 60 tons to nearly 74 tons in its modern, fully loaded configurations. This massive weight creates immense ground pressure. It strictly limits the types of civilian bridges the tank can cross, the military transport planes that can carry it, and the type of soft mud it can traverse without sinking straight to its belly. Third, let us dissect the firepower and the critical human interface. The original M1 Abrams rolled off the assembly line with a 105mm M68 rifled gun. It was highly accurate, but Western intelligence suggested it might not reliably penetrate the frontal composite armor of the newest Soviet T-80 tanks. So the Army quickly upgraded to the German-designed Rheinmetall 120mm M256 smoothbore gun. But the gun tube is only half the lethality equation. The true killing power of the Abrams lies in its advanced fire control system. The tank features a laser rangefinder, crosswind sensors, and a digital ballistic computer that calculates target lead, ambient temperature, and barometric pressure in mere milliseconds. Let us break down the human element of this machine. The United States Army explicitly rejected the mechanical autoloader concept used by the Soviets. They intentionally kept a four-man crew, consisting of a commander, a gunner, a loader, and a driver. Why? Because a machine cannot perform daily track maintenance in the freezing rain. A machine cannot pull perimeter security while the rest of the exhausted crew sleeps. And a well-trained, highly motivated American loader can slam a 40-pound M829 armor-piercing fin-stabilized discarding sabot round into the breach in under 4 seconds. That is significantly faster than the Soviet mechanical autoloader could ever cycle. The Abrams was designed around the core philosophy that the highly trained crew is the most valuable component of the entire tank. The main gun ammunition is stored in a separate, heavily armored blowout compartment in the rear bustles of the turret. If the ammo rack takes a direct hit and detonates, the explosive blast vents upward and outward through blowout panels on the roof, rather than vaporizes the crew inside the fighting compartment. This brings us to the industrial base that makes all of this possible. Building and maintaining the Abrams requires a massive, sustained defense industrial complex. The Joint Systems Manufacturing Center in Lima, Ohio, is a sprawling, specialized facility where these steel beasts are assembled. Over the past few decades, Congress has aggressively kept the Lima plant running, sometimes forcing the Army to buy tanks it did not even ask for, just to preserve the highly specialized welding and manufacturing skills required to build classified composite armor. It is a prime example of how grand military strategy and local domestic politics are permanently welded together in the United States. You cannot fully understand the Abrams without understanding the political engineering that keeps its assembly lines moving. So, by the late 1980s, the United States had successfully fielded an absolute monster. The M1 Abrams was heavy, incredibly thirsty, and astronomically expensive to maintain. It was a silver bullet explicitly designed for one specific nightmare scenario: a massive conventional war against the Soviet Union in the dense forests and rolling plains of Western Europe. It was built to fight in cold weather, heavily supported by an unbroken chain of fuel trucks, and shielded by an impenetrable canopy of F-15 Eagles and A-10 Warthogs. But history has a funny way of completely ignoring the meticulous plans of generals. The Soviet Union was rapidly collapsing under its own weight. The massive, apocalyptic tank battles in the Fulda Gap never actually happened. Instead, the ultimate test for this Cold War Leviathan would come from a completely different direction, in a completely different climate, against a completely different type of enemy. The ultimate proving ground would not be the frozen, muddy fields of Germany. It would be the scorching, featureless deserts of the Middle East, where temperatures routinely soared past 120 degrees Fahrenheit, and the fine, abrasive sand threatened to choke the life out of those delicate, high-performance turbine engines. The supposed paper tiger was about to step into the ring for the very first time, and the entire world was holding its breath to see if this billion-dollar gamble would pay off or burn in the sand. August 1990. Saddam Hussein sends his Republican Guard crashing into Kuwait. The United States responds with Operation Desert Shield, moving massive armored formations into the Saudi Arabian desert. The environment alone was trying to kill the Abrams before the Iraqis even fired a single shot. The fine, talcum powder-like sand of the Arabian Peninsula was the ultimate enemy of the AGT 1500 gas turbine engine. These engines inhaled massive volumes of air, and if that sand bypassed the filtration system, it would turn the turbine blades into molten glass. Maintenance crews had to aggressively clean and replace the VPAC air filters constantly, sometimes twice a day. If a crew got lazy, a $3 million tank turned into a stationary bunker. But American logistics, the unsung hero of every modern war, flexed its incredible industrial muscle. The supply chains pumped millions of gallons of JP-8 jet fuel and thousands of spare parts across an ocean and into a featureless void. Let us look at the Iraqi adversary. The Iraqi army was the fourth largest in the world at the time, heavily equipped with Soviet export T-72 M1 tanks. These export models, derisively nicknamed monkey models by Western intelligence analysts, were severely downgraded. They lacked the advanced composite armor of the premier Soviet tanks, relying instead on conventional steel. They fired older steel core penetrator rounds, not the modern tungsten or depleted uranium munitions. But their most fatal flaw was their optics. The Iraqi T-72s relied on active infrared searchlights for night vision. Turning on an active infrared spotlight on a modern battlefield is like clicking on a massive flashlight in a pitch-black room. It blinds you to the guy with modern night vision goggles, but it tells everyone exactly where you are. Are you starting to see the tactical mismatch here? The Iraqi tank commanders thought they were hiding in the dark, but to an American gunner looking through a forward-looking infrared, or FLIR thermal sight, those T-72s were glowing white-hot against the cool desert background. February 24, 1991. The ground war Operation Desert Storm officially begins. The coalition forces execute the famous left hook maneuver, sweeping hundreds of miles through the trackless Iraqi desert to outflank the dug-in Iraqi army. The Iraqi generals assumed the deep desert was impassable for heavy armor. They were relying on a static defense paradigm, much like the French relying on the Maginot Line in 1940. The French thought the Ardennes forest was impenetrable to German panzer divisions, and it cost them their country. The Iraqis thought the Western Desert was a natural barrier, and it cost them their entire military. The Abrams, guided by the newly deployed Global Positioning System, navigated the featureless wasteland at 35 miles per hour, completely bypassing the elaborate Iraqi minefields and fire trenches to the east. This brings us to the defining moment of the Abrams legend. February 26, 1991. The Battle of 73 Easting. It was a miserable, chaotic day. A massive shamal, a blinding desert sandstorm, had reduced visual range to less than a few hundred yards. Heavy rain and howling winds grounded American air support. The A-10 Warthogs and Apache helicopters could not fly. For the first time in the war, the American tankers were on their own, stripped of their overwhelming air superiority. Captain H.R. McMaster was commanding Eagle Troop 2nd Squadron, 2nd Armored Cavalry Regiment. His unit consisted of 9 M1 Abrams tanks and 12 Bradley fighting vehicles. They were acting as the armored spearhead, probing eastward to find the elite Republican Guard Tawakalna Division. The Iraqis had set up a textbook reverse slope defense. They dug their T-72s and BMP armored personnel carriers into the backside of a subtle desert ridge. In a normal war, cresting that ridge would be suicide. The enemy would have pre-sighted kill zones, waiting to shoot the thin underbelly of the American tanks as they rolled over the top. But this was not a normal war, and the Abrams was not a normal tank. At 16-18 hours, McMaster's tank crested the ridge. Through the blinding sand and rain, his thermal sights picked up the heat signatures of the Iraqi armor perfectly. The Iraqi gunners, completely blind in the storm, had no idea the Americans were right on top of them. McMaster did not halt to call for artillery. He did not wait for the rest of the regiment to catch up. He ordered his 9 tanks to aggressively attack a dug-in brigade of Iraqi armor. What followed was a massacre of industrial proportions. The American gunners loaded the M829A1 armor-piercing, fin-stabilized discarding sabot round. This was a depleted uranium dart flying at over 3,500 feet per second. It was affectionately nicknamed the Silver Bullet. When a depleted uranium dart hits steel armor at Mach 5, it does not just punch a hole. The kinetic energy is so extreme that the armor and the dart both liquefy under the immense pressure. The interior of the target tank is sprayed with superheated pyrophoric metal fragments that instantly ignite the ammunition carousel. Within the first 10 minutes, Eagle Troop destroyed over 28 Iraqi tanks, 16 armored personnel carriers, and 30 trucks. The Abrams tanks were firing on the move, utilizing their 2-axis gyroscopically stabilized turrets. This stabilization system meant the hull of the tank could be violently pitching over sand dunes, while the main gun remained perfectly locked onto the target. The Iraqi T-72s had to come to a complete stop to fire accurately. By the time an Iraqi gunner hit the brakes, manually acquired a target, and pulled the trigger, an American depleted uranium round had already decapitated his tank. Does a battle like this prove the Abrams is invincible, or does it just prove that shooting blind men in a sandstorm is an execution, not a fight? The battlefield mathematics at 73 Easting were absolutely staggering. 0 Abrams tanks were lost to enemy fire. Hundreds of Iraqi armored vehicles were left as burning husks. Similar slaughters occurred at the Battle of Medina Ridge, where the 1st Armored Division destroyed the Medina Luminous Division in a massive, sweeping engagement at ranges exceeding 2 miles. The Iraqi rounds simply bounced off the depleted uranium armor of the Abrams, while the American rounds punched clean through the sand berms and the Iraqi tanks hiding directly behind them. The Gulf War cemented the M1 Abrams as the undisputed king of the desert. It was a public relations triumph that made the tank seem like a mythical beast, impervious to enemy fire. But military technology is never static, and enemies adapt. If you cannot kill a tank head-on in the open desert, you drag that tank into a knife fight in a phone booth. You drag it into the city. Fast forward to April 2003. Operation Iraqi Freedom. The strategic objective is Baghdad. Colonel David Perkins, commanding the 2nd Brigade of the 3rd Infantry Division, makes a highly controversial tactical decision. Instead of slowly besieging the city and fighting block by bloody block, he orders a massive armored thrust straight into the heart of the Iraqi capital. These operations became known as the Thunder Runs. Urban warfare is the absolute worst nightmare for heavy armor. Think of the Russian disaster in Grozny in 1994, where Chechen rebels trapped columns of Russian tanks in narrow streets and annihilated them with RPGs fired from rooftops. A tank in a city is blind, restricted in movement, and vulnerable from 360 degrees. The roof and the rear engine deck of an Abrams have the thinnest armor on the entire vehicle. On April 5th and April 7th, columns of Abrams tanks and Bradley fighting vehicles smashed through the highway network of Baghdad. It was a chaotic 360-degree firefight. The Iraqis threw everything they had at the armor: rocket-propelled grenades, heavy machine gun fire, and suicide car bombs. The Abrams took a severe beating. The complex optics were shattered by small arms fire. The external machine guns were damaged. But the frontal and side composite armor held against the older RPG-7 warheads. The sheer shock and awe of heavy American armor suddenly appearing in the center of the capital broke the back of the Iraqi regime command and control structure. However, the Thunder Runs also exposed the first real cracks in the armor. One M1A1 was struck in the rear engine compartment by a recoilless rifle. The turbine engine was destroyed, leaking highly flammable jet fuel that ignited. The crew safely evacuated, but the tank had to be abandoned in the street. To prevent it from falling into enemy hands, the Americans had to destroy their own tank. They hit it with a thermite grenade, a depleted uranium round from another Abrams, and finally 2 Maverick missiles from an A-10 Warthog just to permanently disable it. It was a sobering reminder that even a 70-ton Titan can be brought down by a cheap weapon if it hits the Achilles heel. As the conventional invasion morphed into a grinding, multi-year insurgency, the vulnerabilities of the Abrams became glaringly obvious. The insurgents were not fighting a conventional war. They were fighting an asymmetric war of attrition. They realized they could not penetrate the frontal armor, so they completely stopped trying. Instead, they buried massive improvised explosive devices, or IEDs, deep under the asphalt. We are talking about heavy artillery shells wired to washing machine timers, packed with hundreds of pounds of military-grade explosives. When an Abrams drove over a deep-buried IED, the blast wave hit the flat, relatively thin belly armor of the tank. The sheer concussive force could launch a 70-ton tank several feet into the air, snapping the torsion bar suspension, shattering the crew's spines, and completely destroying the vehicle. The United States military had to quickly adapt, fielding the Tank Urban Survival Kit known as TUSK. This rapid upgrade added explosive reactive armor blocks to the side skirts to defeat shape charges, slat armor to the rear to protect the engine exhaust, and transparent armored gun shields for the commander and loader who had to expose themselves to fire the external machine guns. But the insurgents adapted again. They introduced the explosively formed penetrator, or EFP. This was a brutally simple Iranian-supplied weapon. It was basically a concave copper disc backed by high explosives, hidden inside a fake rock or a piece of trash on the side of the road. When triggered by an infrared sensor, the explosive deformed the copper disc into a molten slug traveling at hypersonic speeds. It did not care about classified composite armor or explosive reactive tiles. An EFP would punch straight through the side of an Abrams, spalling molten copper and steel directly into the crew compartment. The mighty Abrams, the tank that had annihilated the Republican Guard from miles away, was now bleeding out in the narrow alleys of Sadr City and Fallujah. It proved that in urban counterinsurgency there is no such thing as an invincible vehicle. The American military learned the hard way that a multi-million-dollar machine can be countered by a $30 copper plate and a garage door opener. The paper tiger accusations began to surface loudly. Critics argued that the tank was a Cold War relic, too heavy for modern bridges, too thirsty for long-range patrols, and entirely unsuited for the complexities of asymmetric warfare. Yet the tank survived the insurgency. It evolved. It gained weight, it gained new sensors, and it remained the heavily armored fist of the United States Army. But, as the global war on terror slowly wound down, a new, much more terrifying shadow was falling across the battlefields of Eastern Europe. The rules of armored warfare were about to be violently rewritten by a technology that no tank designer in the 1970s could have ever predicted. The sky was no longer filled with friendly A-10 warthogs, but with something small, cheap, and utterly lethal, waiting quietly in the clouds. The sky over the modern battlefield is no longer a sanctuary, but a hunting ground. We are looking at the muddy, shell-pocked fields of Eastern Europe in 2023 and 2024, specifically the contested zones around Avdiivka. The United States government finally agreed to send 31 M1 situational awareness Abrams tanks to the Ukrainian 47th Mechanized Brigade. These were not the top-tier, depleted uranium-armored behemoths used by the American military, because federal export laws strictly prohibit the transfer of classified uranium armor packages. Instead, these export models were retrofitted with tungsten-heavy alloy armor. The world watched with bated breath, expecting these legendary machines to punch through Russian defensive lines, just as they had annihilated the Republican Guard in Iraq. But the environment they entered was fundamentally alien to the American doctrine of armored warfare. The Abrams was suddenly stripped of its most critical survival mechanism. It had no close air support. There were no F-35 Lightning IIs or Apache attack helicopters clearing the path ahead, and no massive, secure logistical convoys trailing safely behind. Instead, these 70-ton Titans were thrust into what military strategists call a transparent battlefield. Above the tree lines, a terrifying new apex predator was waiting. The first-person view, or FPV drone. We are talking about commercially available, plastic quadcopters that cost less than $500, modified in basements to carry a cheap mass-produced PG-7V shaped charge warhead. The operator is not a highly trained pilot sitting in a multi-million-dollar simulator, but a 20-year-old soldier wearing virtual reality goggles, hiding in a trench 3 miles away. How does a $500 plastic toy kill a $10 million main battle tank? It attacks the geometry of the armor. The Abrams was designed during the Cold War to survive massive frontal kinetic impacts from other tanks. Its frontal turret cheeks are over 2 feet thick with advanced composite matrices. But the roof of the turret, the engine deck, and the blowout panels over the ammunition compartment are covered by merely 1.5 to 2 inches of rolled homogeneous steel armor. An FPV drone operator simply flies the drone directly down into the open commander's hatch, or slams it into the thin rear engine grille, instantly destroying the AGT 15500 gas turbine engine and turning the tank into a stationary burning pillbox. Does this sudden vulnerability mean the tank is completely obsolete? We have to look back at military history to understand this paradigm shift. Think about the summer of 1921. American Brigadier General Billy Mitchell was desperately trying to prove that air power was the future of warfare. The United States Navy brass laughed at him, believing that heavily armored battleships were the invincible kings of the sea. Mitchell took a squadron of flimsy Martin MB-2 biplanes, armed them with 2,000-pound bombs, and sank the captured German dreadnought Ostfriesland off the coast of Virginia. The admirals were stunned. Mitchell proved that no matter how thick your side armor is, if you cannot protect your roof from cheap airborne munitions, you are just a massive steel coffin waiting to sink. The Abrams, and indeed every modern main battle tank on Earth, is currently experiencing its own Billy Mitchell moment. The threat vector has permanently moved from the horizontal plane to the vertical plane. To counter this, we have seen the rapid, desperate evolution of field-expedient armor. Tank crews are welding massive steel grills, derisively called cope cages, over the roofs of their Abrams tanks. They are bolting on electronic warfare jammers designed to sever the radio link between the drone and its operator. But this is a chaotic game of cat and mouse. The moment a jammer is deployed, the enemy shifts the drone's operating frequency. The moment a cope cage is welded on, the enemy uses a tandem charge warhead to punch through the cage and the roof armor simultaneously. The tank is gaining more weight, becoming more top-heavy, and losing its crucial situational awareness as the commander's field of vision is obscured by a cage of welded rebar. But the drone threat is only the tip of the tactical iceberg. We have to examine the brutal, unforgiving reality of logistics in a peer-to-peer conflict. The Abrams is not just a vehicle. It is a highly sensitive ecosystem that requires a massive, dedicated umbilical cord of support to function. Let us break down the maintenance nightmare. When an Abrams is operating in the deep freezing mud of the Rasputitsa season in Eastern Europe, the tracks take immense strain. If a tank hits a hidden TM-62 anti-tank mine, it blows off the track and shatters the road wheels. In American doctrine, an M88A2 Hercules Heavy Equipment Recovery Combat Utility Lift and Evacuation System, a massive armored tow truck weighing over 70 tons itself, is immediately dispatched to hook up the disabled Abrams and drag it back to a secure maintenance depot. But on a transparent battlefield, where enemy Orlan-10's surveillance drones are constantly watching from 10,000 feet, the M88 recovery vehicle becomes the primary target. If the enemy artillery destroys the M88, you now have two 70-ton vehicles permanently stuck in the mud. The Ukrainian crews often have to abandon perfectly functional Abrams tanks simply because they threw a track in the gray zone, and recovering them is a suicide mission. Furthermore, the AGT-500 turbine engine is a prima donna. It provides incredible horsepower, but it demands absolute cleanliness. The VPAC air filtration system must be meticulously blown out with compressed air. If a crew is under constant artillery bombardment for 3 days straight, they do not have the time or the safety to perform depot-level maintenance. The engine ingests dirt, the turbine blades warp, and the tank dies of mechanical failure before the enemy even fires a shot. We can compare this immense logistical burden to the famous Red Ball Express in the autumn of 1944. After General George S. Patton's Third Army broke out of the Normandy beachhead, his armored spearheads raced across France at breakneck speed. But they completely outran their supply lines. Patton's Sherman tanks were burning over 350,000 gallons of gasoline a day. The entire Allied advance ground to a halt, not because the German panzers defeated them, but because the American supply trucks could not physically carry the fuel fast enough. The modern Abrams burns vastly more fuel than a World War II Sherman. If you sever the logistical chain, or if you simply cannot establish one in a contested environment, the Abrams is nothing more than a 70-ton roadblock. This brings us to the broader economic and political dimensions of the Abrams program. War is ultimately a brutal mathematical equation of cost and attrition. A fully loaded M1A2 SEP version 3, the current gold standard of the American armored fleet, costs anywhere from $10 to $24 million depending on the specific communications and armor packages included. When a $10 million asset is routinely destroyed by a $500 hobby drone, the economic exchange ratio becomes completely unsustainable for any nation, even the United States. This economic mismatch echoes the strategic failures of the Vietnam War. During Operation Rolling Thunder, the United States military routinely used multi-million-dollar F-105 Thunder Chiefs and F-4 Phantoms to bomb $10 bamboo bridges and dirt supply trails. The American forces won virtually every tactical firefight, but they lost the strategic war because the cost-exchange ratio and the political will were fundamentally mismatched against an enemy, fighting a cheap, asymmetric war of attrition. You cannot win a modern war of industrial attrition if your primary weapon system costs 10,000 times more than the weapon used to destroy it. Yet, despite these glaring vulnerabilities, the United States continues to build and upgrade the Abrams. Why? Because military procurement in America is deeply intertwined with domestic politics. We have to look at the Joint Systems Manufacturing Center in Lima, Ohio. This sprawling, government-owned, contractor-operated facility is the only place in the United States that can forge the heavy composite armor and assemble the Abrams. In 2012, the United States Army Chief of Staff, General Ray Odierno, famously went before Congress and explicitly stated that the Army had enough tanks and did not need any more. He wanted to pause production to save money for other modernization programs. Did Congress listen to the top general in the Army? Absolutely not. Congress authorized hundreds of millions of dollars to keep the Lima plant open and force the Army to buy tanks it did not request. They did this because shutting down the plant would mean losing thousands of highly specialized manufacturing jobs in a critical swing state, and it would permanently destroy the specialized supply chain of welders and engineers required to build heavy armor. The Abrams is not just a weapon of war. It is a massive political jobs program scattered across dozens of congressional districts. This is the reality of the military-industrial complex. The tank will continue to roll off the assembly line, regardless of whether the tactical realities of the battlefield demand it. So, we return to our original uncomfortable question. Is the M1 Abrams the ultimate battlefield legend, or is it an overrated paper tiger? The truth, stripped of all the Pentagon public relations and the Hollywood glorification, is brutally pragmatic. The Abrams is neither an invincible god of war nor a useless piece of scrap metal. It is an apex predator, but like all apex predators, it requires a very specific, carefully controlled habitat to survive and dominate. When the Abrams operates within the American military doctrine, supported by an unbroken chain of fuel trucks, shielded by an impenetrable umbrella of fighter jets, and flanked by highly trained mechanized infantry to clear out anti-tank teams, it is the most lethal land system ever devised by human engineering. It will hunt and destroy any armored vehicle on the planet. But if you strip away that habitat, if you deploy it in isolation, without air cover, without spare parts, and expose it to the swarming, vertical threats of a transparent battlefield, it becomes a massive, vulnerable liability. The tank is not dead, but the era of the tank operating with impunity is over forever. The steel beasts must adapt to the buzzing of the drones, or they will go the way of the battleship, sinking into the mud of history. War does not care about your legacy, your price tag, or the thickness of your frontal armor. War only cares about who adapts faster to the bleeding edge of the sword. Thank you for stepping into the war room with us today. Now it is time for you to make the call. Based on the tactical realities of the modern battlefield, do you think the M1 Abrams is A, still the undisputed king of the battlefield that just needs better tactics? B, a highly capable machine that desperately needs active protection systems and anti-drone lasers to survive? Or C, an obsolete Cold War relic that should be entirely replaced by unmanned ground vehicles? Drop your answer, A, B, or C, down in the comments below and let me know your strategic reasoning. Hit that subscribe button to keep your tactical edge sharp and keep your powder dry.